So good morning, everyone. We'll get started. It's not easy to follow Vincent. He always do great presentations. So I'll do my best this morning to keep you awake, and hopefully you like my presentation. My presentation is very aligned with what we saw. But it's the same story, but from an implementer's point of view, a broadcaster in a practical approach. So it's about using the EBU's dynamic media facility concept that we learned about and what we've done with them during the Milano-Cortina Olympic Games last month, and what we learned from the experiment. I don't want to go back to everything Vincent said. We should have compared the presentation first, but we have a QR code. So if you want to go more into the detail and get access to the reference architecture that was just updated on the EBU's website, feel free to scan the QR code and read the documentation. The DMF, Vincent talked about the layered model. There's also an important concept, which is the life cycle of the workload. And workload is a production. If we want our infrastructure to be dynamic, the production cannot be always on. So it has to be planned. It has to be instantiated. We use it after we finalize, review, and we start the cycle once again. So that's another very interesting concept of the reference architecture. Part of the reference architecture, there is the media exchange layer. We're very often asked, are DMF and MXL the same thing? MXL is a component of DMF, but no, they are not the same thing. The SDK is available right now. It was published on February 26th. That's an important date for this presentation, February 26th, because the Olympic Games started 20 days before that. So we more on this later. But the thing is, it is available. It is there. Version 1.0 means that if you want to use it, you can expect that the API is fairly stable and that it will not change. It might evolve, but no big change plan for version 1.1 and future versions. Then there's also an initiative called the GTDMF that Vincent talked about. Again, we have a QR code. So if you want to learn more about the keyword tracks, you can read. And if you are a member of either the EBU or a member of the AMWA, you can participate in those initiatives. There's a lot of work. So if you want to participate and be active, there's a place for you in those discussions. Then what have we done with the DMF concept? This is a very, very simple workflow that many rights holder of the Olympic rights do all the time. They take an event that it's pre-produced by OBS and they transmit that directly on their platform. Could be digital, could be linear, but a simple pass-through of the feed is possible. The signal we purchase from OBS are fully produced, ready to be used on air, fully QC'd. The problem with that is we don't bring a lot of value as a public broadcaster or as a broadcaster. It's not the best way to connect with the audience. And if you don't speak English, well, those commentary provided by UBS are English. So very often you need at least to change the commentaries to make them a little bit more appropriate for your own market. So what most people do is that they will have a booth at home or they can have a booth at the venue. Both is possible. Not a booth, but a commentaries position, and they simply take the commentaries from OBS. They will intercept them, remove them, and mix the international sound with locally produced comment, and that's it. What we do a lot at CBC, you can imagine that those feeds are not free, so you need a way to monetize or pay to support the whole production. So our workflow at CBC is that we have employees that watch the feed, and it's a very simple workflow. I call that the boring button. So they have a single button, and when when there's not too much action in the feed, they press the boring button and it inserts a Scotty marker in the signal so that we can have a downstream process that will insert an ads to help to monetize that content. So again, we don't provide much more value as a broadcaster by staying to that workflow. So the question we were asked by the Olympics team within CBC is, how can we improve the production value? Means add more content to the feed so that our viewers feel that those feeds were produced for Canadian audience without increasing the costs, and maybe, hopefully, at the same time, generate additional revenues. And when we say without increasing the cost of a production like that, very often it's human resources. It's not necessarily equipment, but if you need a full control room to add more production value, it becomes really expensive. So in the past, we were doing a bit more production on some of the feeds, and that was requiring the use of a traditional control room or a simple version of it, simpler version, but still, you need people, you need equipment, and games in parallel, events, you can have 5, 10, 15 of them, and we don't have 15 control rooms available to do that. So this is, it's a workflow that works, but it is a workflow that is costly, both in terms of human resources as well as equipment. So phase one of the project, can we leverage DMF ideas? So we replace the backend of the control room by server. There's one server in the picture. Of course, it was a cluster of a few servers. There's a bit more than one, but you get the idea. We use basically the same employee that was tasked to insert the Scotty marker to be able to control more of the productions, but it had to be easy, so we're not increasing the head count required to deliver the production. So this is the phase one. You can see in that picture that there is still a booth. That booth there is in Toronto on a studio floor that is used to create local comment, the commentators and the descriptor inside the booth. They are using today traditional equipment where we have mics, audio interface, monitors, screens to capture their voice and so that they can see the event. But there's a phase two of the project, and the phase two of the project, from a technical point of view, it was delivered, but from a user point of view, operation felt that there's so much change we can handle at once. So let's do phase one, and next event, let's move out to phase two. But the phase two is that the commentator could have a single laptop where they see the event. They have very few control, a cough button, audio levels, and so that they can control the gain of their headphones. And that's about it. So that's technology is delivered, but to be used in operation is a future phase. So what can we do with that system? We can play clips, and those clips can be used for show opening, show closing, bumpers before and after the commercial breaks. We can also insert the name of the commentators. Commentators for sports are almost always well-known athletes that have retired, or coaches or people known by our public. So to see their face and have their name brings a bit of additional value. We can generate lower thirds, so those can be used for ads or placement of other program event we do. We can also do squeeze back, which is another version of another way to insert graphical content. The user interface, that's something that it's one of the learning we made, is that having a single laptop is not enough if the user needs to go between multiple tabs in their browser. So we were asked, it has to be a single screen where all of the control needed are properly laid out, and that's it. No moving between tabs or Chrome session, no external monitors, just one. So and that created a problem, because that workflow, the most important thing, yes, it is to add comments, but it is also to be able to add the Scotty marker in the signal. And very few tools we saw that were all-in-one tool were able to combine that Scotty marker section with the video section, with the control of the graphics and the clips and everything. So we decided to build our own interface where we have a place that we can insert the duration of a trigger, start the trigger, the operator, they have an objective of X amount of ads per hour. So where are you in your objective? Are you a little bit over, under? So all of that is on the right side of the screens. And that kind of forces us to build a custom UI. But another good learning is that when the tool you're using provide good API, well-documented API, build your own user interface on top of it is not trivial, but it's not rocket science either. It's really not that much complicated. So here we have this one. I don't like it, the picture, because typically it was done during training, not during the actual show. So normally the commentator, they see the raw feed. They don't see the produce output that goes on there. So please don't mind the lower third, but that's the commentator interface. So very simple, cough button, mute, audio level, and that's pretty much it. We use that for curling. Why curling? Because it is quite popular in Canada, especially in the western side of the country. We needed an event that was challenging enough so people don't like to fail, but still when it's a popular sport, it brings just the right level of pressure so that people want to succeed. And still ice hockey, maybe it's a bit too much. So we went with curling. We were able to insert 676 promos during the show, branded promos. We were able to use the tool for 144 hours on air. This is actual usage on air. And we don't have it there, but we had some peaks on a Wednesday afternoon where we had 500,000 people watching those streams on digital only, not linear, not just our own app, which was better than expected. So that is great. Another benefit, and we'll see how we build that, but I really like that story, is we want to leverage software and DMF concept to bring production agility. That's the whole thing, is to be able to quickly say yes to requests from production. Then in the past, the answer would have been yes, but in a month, or yes, but in a week. And what happened is that producers from CBC Sports and NPC Sports heard that both of the network were having journalists and specific watch parties across both countries, and they wanted to exchange the signals so that NBC and their production, when they score a goal, they could see someone in a watch party with a sad face and vice versa. So, or a happy face, or you get the idea. So that was put together very, very quickly because the whole pipeline is software, and it's a matter of basically connecting things together and don't having to worry about purchasing, racking, installing, and configuration was quite quick. So this is a very interesting bonus. So how was it built internally? There's a lot of ways to achieve that workflow in software, but none of them could do 100% of what we needed in terms of audios, cutting markers, a single UI, automation, so that a single person could operate everything. So we put together a couple of partners in that production. The goal is not to have one partner per function. So if you see there's everything video in the pipeline is mostly Grass Valley. It was one partner. Everything audio is another company called Honorts. Everything that is automation is another company that worked with us, which is, the product is called Cues from a company called Tinkerless. The graphics were HTML5 graphics done with SPX which is an HTML5 graphic solution. And there is a little bit of FFmpeg we use in this and another open source project called MediaMTX, which is a way to bring WebRTC video in a browser. MediaMTX is worked very well for us to do that, but it required some video manipulation, so we use FFmpeg in between and audio encoding also in order to do that. So this is the production pipeline. You can see that almost everything from the video side is a Docker container today. So to say we will containerize production equipment today, it is possible. And as I was building a presentation, it's easy because in JVM, you know if this is a container or not right from the App Store. And with the exception of the ancillary processor added at the end, everything is a Docker container. Everything we build ourselves. Was deployed using Kubernetes, so they are container. Also, the audio solution was not containerized due to some performance issue we had during testing with the containerized version of the workflow. So we decided to, yes, it's a Windows application, but it works. So for production, we'll go with that. But since then, that has evolved, and there's a little bit of the workflow that was also in the cloud because the Q solution is a cloud native solution with a little bit of code that runs locally because those production control queues needs to be very low latency, but it's mostly a web-based solution. I said that the MXL SDK was released on February 26th. The Olympic Games started on February 6th. That whole pipeline was fully delivered, commissioned, tested before Christmas. We tried to work with the team, although MXL was not released at the beginning of the game. Can we try it? And we made I guess the best decision not to do it because it's a little bit risky to go with fresh code that never went on air for the Olympic game. But still, we build in parallel in non-prod the exact same workflow, but where we made one noticeable change, where the output of Grass Valley AMP was shared to the WebRTC server using MXL. And that really helped to reduce the latency of that sharing between the both. And another lesson we learned, and for us it was the first time, but we were able to run our own container inside the JVM infrastructure, and it did work well. And with careful planning, if you do things wrong, they can step off each other's toe. But if you do it the right way, we didn't have any issue. The FFmpeg container is also GPU accelerated, so we were able to share the GPU, not the same GPU, but still have GPUs in the machine used by AM and used by our own FFmpeg container. That worked well in non-prod, and since now the game are done, the version we have for future event is this one, which is MXL based. Just to finish, maybe to make it a little bit more, to align what we did with what Vincent showed about the layer. Internally, we have some kind of a branding name. There's the Dynamic Media Facility. The tool we use to do live content, we called it Dynamic Live, and the backend infrastructure that supports that, we called it Dynamic Core, but this is CBC terminology. It has nothing to do with the official DMF terminology. So part of our Dynamic Core, the IT infrastructure that supports all of that is fully cut. It is Dell servers, but it could be another vendor server. NVIDIA GPU, but again, it could be others people's GPU, and NVIDIA NIC cards and Intel NIC cards. We have other vendors, but still very standard NIC cards. On top of that, today we have some machine for various reasons that runs Ubuntu, some machines that runs Alma Linux, and it's not yet 100% confirmed, but more than likely we'll move everything over to Ubuntu because it is much easier based on our little experiment so far for GPU support on Ubuntu, it is easier, but you may have different results on your side. Container platform, it's a mix of simple Docker with Kubernetes. The Kubernetes distribution we use is K3S, which is a lightweight Kubernetes distribution designed for edge or Internet of Things at the edge implementation. So far, it works well for us. Then application and user interface are not part of dynamic core, so we'll skip that. Then we have media functions. The media functions are in our workflow. It's the audio mixer, it's the multi-viewer, it's the clip player, it's the HTML5 graphics renderer. So we had a bunch of media functions running in the workflow, and they are interconnected together today, or what we use at the game, with a mix of 2110 and RTMP, where in the future we want to move as much as possible towards the MXL SDK. And then there's the vertical section, column or functionality that Vincent spoke about before, that were also we have specific solution for each of them, but they're not all deployed. There's still a lot of work to be done in the control, orchestration, monitoring area. So that's it. I have 5 seconds, so I don't know if there is one quick question. We have question, comment, objections? No? Good. So have a good day. Thank you.